All right, guys, on this question, they're asking us to identify the GCF of the above polynomial. So you got to ask yourself what's in common in regards to the numbers. What multiple is in common? And you don't want just a regular multiple. You want the greatest multiple and the greatest common factor. So when you think about 18, 54, and 36, it's not enough to pull out a 2, right? Because there's bigger values to pull out. So don't do that. The number 3 might work. This is divisible by 3. I believe this is divisible by 3, and that's divisible by 3. But even bigger, the number 9 is better. So let's work with 9. Then how many x's could we pull out of all 3 terms? There is a maximum of 5 that you could pull out of all 3 terms. So 9x to the 5th. So when we say 9 times what will get us back to 18, that is 9 times 2 getting us back to 18. When I say x to the 5th times what will get us back to x to the 12th, that would be x to the 7th. And then 9 times what gets us to negative 54. 9 times negative 6 gets us to negative 54. And then x to the 5th times what gets us x to the 6th, that'll be another x. And last but not least, 9 times what gets us a negative 36, that will be a negative 4. And then 9 times, or x to the 5th times what gets x to the 5th, that's it. Now, notice, guys, that I look at the inside and I still have 2, 6, and 4. That means I could have pulled out another multiple of 2. So this is definitely not my GCF. Don't type this in, or don't select this one, because you could still pull out a 2 from here, a 2 from there, and a 2 from there. So imagine if I were to pull out a multiple of 2. So I'd put a 2 out here, and if I pull out the multiple of 2, pull out the multiple of 2, pull out the multiple of 2, then I will have x to the 7th minus 3x minus 2 in those parentheses. And what you would have outside would be 2 times 9, which would be 18, x to the 5th, okay? So it would have been easier to identify right at the beginning, oh, there's 18 right there, 18 right here, and 18 right there. But since I didn't notice that right from the start, I did notice a multiple of 9 in each one of them. I still looked at the inside, and there was still the multiple of 2 to pull out from all these 3 terms. So I pulled out the multiple of 2, and that gives us 2 times 9, which gives us 18. So the GCF is 18x to the 5th. 18x to the 5th is the GCF. That would be this answer right here. On this question, they ask us to completely factor and then type in our answer. So what does completely factor mean? Well, just start by pulling out your GCF and see if there's anything else to do. So I could pull out the GCF of 2. What would be left is an x squared minus 11x plus 24. Now, if we look at the inside, we have a quadratic trinomial now that does have the a value of 1. So this is what I'm going to do. I'm going to take this quadratic trinomial. Since the a value is 1, I could try this with the x right there and the x right there and simply think, what times what is my c value of 24 that if I combine together is my b value of negative 11. So I want to make a list of the multiples of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and those are all the possible multiples of 24. Now, which pair combines together to give us the middle value, negative 11? Well, if I go 4 plus 6, that's 10, that's not negative 11. 3 plus 8, that is 11, but not negative 11, but I do get an 11. So right here I have the right numbers, just the wrong signs, because I need it to be a negative 11, not a positive 11. So I have the right numbers, just the wrong signs. Just change it to a negative 3, change it to a negative 8, and you're good to go. Negative 3, negative 8, and don't forget about the 2 that you originally pulled out. That needs to be in front. So ladies and gentlemen, you're going to type in your answer exactly like this with no spaces between your terms. It'll be 2 parentheses x minus 3 parentheses x minus 8. Okay, on this question here, the very first thing you want to do is make your quadratic formula or quadratic equation equal to 0. So let's first subtract 3 and rewrite it. So our new quadratic equation will be 12x squared plus 5x minus 3 equals 0. Now you could try to factor it and then split it and solve it, but I wouldn't do that because the a value is 12. I mean, you could, You could definitely do that, but I think the quadratic formula may be a little easier in this case. I'm going to identify my a value of 12, my b value of 5, and my c value of -3. And now I'm going to use the a value, b value, and c value, and I'm going to plug it into the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And when you use this formula, please use parentheses like so. Okay, so let's plug in our b value right there and right here, the b value, which is 5. So I'm going to take that positive 5 and put it right there and right there. Then we're going for the a value right there and down here. So the a value is 12, so we're going to put it right there and down here, 12. And finally the c value. The c value is clearly -3, so that's -3 right there. Now let's do the math. Whenever we do this math, it's good to start with the discriminant, the value inside the square root. Inside the square root, it's good to begin with the exponent. 5 squared is 25. I'm going to jot that down on the side. And then after that, I'm going to actually multiply -4 times +12 times -3. And you could use a calculator for that. That will be 144 positive. So that'd be plus 144. Okay. And of course, that is still inside the square root. So when I add 144 plus 25, my discriminant is really 169, which is a perfect square number. So let me rewrite my entire quadratic formula, but instead of the discriminant being this, I'm going to put the 169 in there. So I really do have x equals -5 plus or minus the square root of 169 divided by 24. 2 times 12 is 24. Now 169, if you do this on the side, the square root of 169 is equal to 13. So we're going to simply replace x equals -5 plus or minus 13 divided by 24. And this will provide us with 2 answers. You have your -5 plus 13 divided by 24, and you'll also have your -5 minus 13 divided by 24. So up on top, up here, when I go -5 plus 13, that will be an 8, and 8 divided by 24 could reduce by 8 to give you a 1/3. So 1/3 is an answer. Okay, let's go to the other situation, the -5 minus 13. That will be -18 over 24, and that you could reduce by 8, no, by 6. Yeah, by 6. So if you reduce by 6, you'll end up with a -3 over 4. So your 2 answers are 1/3 and -3/4. Those are your 2 answers, 1/3 and -3/4. And you look for that, there is no positive 1/3 and -3/4. So it must be none of these are correct. On this question, the easiest thing to do would be to isolate. So we're going to divide by 5, and we will have x minus 3 squared equaling 4. And I now need to get rid of that square by doing the inverse operation, which would be a square root and square root. So I will have an x minus 3 equaling 2. But then again, remember, whenever you apply a square root, you must put a plus or minus in front of your answer whenever you apply a square root in an equation. Now for my final step, I need to get x by itself, so I need to add 3 and add 3, but the plus or minus 2 make it weird. So let's take this positive 3 and just put it in front. So here's my answer. X equals the positive 3 with a plus or minus 2, and that will actually produce 2 answers, the 3 plus 2 and also the 3 minus 2. So the 3 plus 2 is 5, the 3 minus 2 is 1, and those are your 2 answers, 5 and 1, and there's your answer right there, 5 and 1. On this particular question, you could choose to solve this however you want. I would first start by setting it equal to 0. I want to subtract 6x. I will have 3x squared minus 6x equals 0. Now you could say, oh, my a value is 3, my b value is negative 6, and my c value is 0 because there's no c value right there. And you could use a quadratic formula, but the easier thing to do would be to factor out a GCF. So let's put parentheses down here, and let's take a look at both of these terms. And what is a GCF that we could pull out? That would obviously be a 3 and also an x. So 3x is the GCF. So you have a 3x out here. And now what would be left over on the inside if you did pull out a 3x from both of these? 3x times what will get you a 3x squared? That would simply just be x. 3x times x gets you a 3x squared. How about 3x times what will give you a negative 6x? That will be a negative 2. So we have factored out the GCF of 3x. And now because we have this in factored form as something times something else equaling 0, we could use zero product property to split them and solve, set them each equal to 0 and solve. So I really have a 3x that could be equal to 0. And over here my x minus 2, I'm sorry about that, x minus 2, that also could be equal to 0. And if we solve both of these equations, well, this one just divide by 3, you will have your answer x equals 0. And over here, plus 2, you will have your other answer x equals 2. So your two answers are 0 and 2. And you're going to type it in exactly like that, x equals 0, x equals 2, no spaces between your terms, with a comma separating them both. Alternative answers, check it out. Of course, you could write it the other way. Instead of x equals 0, x equals 2, x equals 2, comma, x equals 0. Anyway, that is how you do that problem. And you could have used a quadratic formula, but I think it's way easier to factor, split, and solve on this one. Another question right here. You could use the quadratic formula and say that your a value is 9, your b value is negative 12, your c value is 4. I'm noticing that we have a perfect square term in the front, perfect square term in the back, so it might be a good idea to just try to use that trick that we square root the first part, square root the last part, and then plug it into the answer format answer, see if it works. What's the square root of 9x squared? It's 3x. What's the square root of 4? It's 2. So we really have a 3x and a 2, a 3x and a 2. Now let's make sense of what symbols belong right here and here. In order for us to get a positive 4 at the very end, it's either going to be a positive 2 times a positive 2 to give you a positive 4, or maybe a negative 2 times a negative 2 to give you a positive 4. It cannot be where one's plus and one's minus. That'd be incorrect because that would eliminate the middle term. Now, since our middle term is negative, that's telling us that both of them are negative. So let's just double check. 3x times 3x, that really will give me a 9x squared. 3x times negative 2, that's negative 6x. Negative 2 times 3x, that's another negative 6x. And when we combine them, it really will give us that negative 12x. So I know that the shortcut here works. Now it is set equal to 0. So now that we have something times something equals 0, you could split them each and set them each equal to 0. So when I do that, 3x minus 2, set it equal to 0. 3x minus 2, set it equal to 0. We already know that these are the same identical answers. So we're not going to write the same answer twice. Let's just solve and write that single answer down. So plus 2, your new equations, 3x equals 2. Final step, divide by 3. Your answer is x equals 2/3. Again, just one answer. If you were to think about this visually, your parabola would only touch the x-axis at one point, not at 2. And what's your answer choices? It's that first one right there, x equals 2/3. This next question is probably one of the easiest ones because it is factored already. It's set up for you to just split and solve using the zero product property. What do I mean by that? Anytime you have something times something else equaling 0, that first something could equal 0, and that second something could also equal 0. So when you solve this, plus 3, you end up with 2x equaling 3, and then final step, divide by 2. That's your answer, x equals 3/2. That's one answer. The other answer would be x equals negative 1. So those are your two answers, 3/2 and negative 1. And if you look at your multiple choices right here, we have negative 3/2 and positive 1. That's not it. So obviously the final answer is none of these. On this one, solve that guy? Well, first instinct should be to try this, right? Because if your a value is 1, then you could set this up and hopefully it works. What times what is 13 that if you add together is 8? We know it does not work. It's not factorable. It just doesn't work. So what we need to do is use the quadratic formula to get this done. There's the quadratic formula, and of course when you use the quadratic formula, replace your variables with parentheses. That's the safest thing to do. And of course our a value we said was 1, so we put a 1 down here and up here. Our b value is clearly 8, so let's put an 8 right here and right there. And the c value is clearly 13, so let's put a 13 right there. Doing the math of the discriminant first, we begin with 8 squared, that is 64. Just jotting that number to the side. And then from there, I do 4 times 1 times 13. And with that negative, it'll be a minus 52. And of course, you could use a calculator. So we have 64 take away 52. And that is inside the square root. That is our discriminant value. So rewriting everything, we have a negative 8. We have a plus or minus. We have the square root of, what is 64 take away 52? That is 12. And of course, it's all over 2 times 1, which is 2. So now at this point, we need to take the square root of 12 and simplify it. The square root of 12 is not a perfect square number, so you want to rewrite it with multiplication to get a perfect square number. 4 times 3 is the good combination. Split the root, you will end up with 2 square root of 3. So we're going to rewrite this thing. This whole thing, we're going to rewrite it. It's going to be a negative 8 plus or minus. But instead of the square root of 12, I'm going to put 2 square root of 3. And it is all over 2. Now, this is all divisible. It's all reducible by 2. So if you reduce by 2, you'll get a 4. Reduce by 2, you get a 1. Reduce by 2, you get a 1. So your final answer is 4 plus or minus 1 square root of 3 over 1. So you don't need the 1 in front of the square root of 3, and you don't need it as a fraction over 1. There's your final answer. 4 plus or minus the square root of 3, which is this answer right here. Solve. And once again, whenever you're going to solve, doesn't matter if you're using the quadratic formula or if you want to attempt to factor, split, and solve, please set it equal to 0. Subtract 30, rewrite it. X squared plus x minus 30 equals 0. Because my a value is 1, I'm going to jump right into this and at least try to think what times what is my c value of negative 30 that if I combine together is my b value of positive 1. And of course I want to make a list of the multiples of negative 30 over here. That's negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4 doesn't work, negative 5 times 6. Those are all the possible ways of multiplying numbers together to get negative 30. So which pair of numbers combines together to give us the b value of 1? That's 6 plus negative 5, or negative 5 plus 6. That'll give us a positive 1. So this is the correct pair of numbers that we want. You don't change any signs, just bring it down, a negative 5 and a positive 6. And this is your factored form of this quadratic trinomial. So it's still equal to 0. We still need to solve it. When you have something times something else equals 0, we're going to split them and solve them each set equal to 0. So I have a x minus 5 equals 0. I have a x plus 6 equals 0. So what are my two answers? X equals positive 5 and x equals negative 6. Those are the two answers to this problem. Last but not least, we need to solve this guy. And of course, you could move the 24 over and have the a value of negative 3, the c value of negative 24, and the b value of 0 and use a quadratic formula. But why would you do that when you could simply just get rid of the multiplication of negative 3 by dividing by negative 3? You end up with x squared equaling a negative 8. And then from there, it's a piece of cake because you square root and square root. You will end up with x equaling, don't forget, when you apply a square root in an equation when you're solving, you have to put a plus or minus in front of your answer. And now the question is, what is, over here, this on the side, what's the square root of negative 8? That's really I square root of 8. And then 8 actually breaks down to 4 times 2 and split the root. and you still have the I out in front. So you really have I times the square root of 4 really is the nice, beautiful number 2, and you still have the square root of 2 over here. All you got to do now is rearrange it in the correct order. Put the number first, the variable next, and then the square root at the very end. So there's your answer. X equals plus or minus 2I square root of 2.